So we just finished ellipses, and I want you to know the differences between ellipses and hyperbolas. First of all, on an ellipse, A is always bigger than B.
A is always bigger than B.
We're going over this sheet right here.
Yes.
In a hyperbola, there is no relation between A and B. A could be bigger than B, A could be equal to B, and A could be smaller than B. So that's not how you determine A and B. So you got to change your mindset when you're doing hyperbolas, okay? And keep looking at this cheat sheet as you're working. In an ellipse, x squared and the y squared term are both positive. But in a hyperbola, one is positive and one is negative. You're going to have one negative term. You saw that last night when you were putting them into format, right?
Yeah.
Then you determine the direction of an ellipse wherever the A is. So if A is under the x squared, it's horizontal. And if A is under the y squared, it's vertical. And you determine the direction of a hyperbola by if y squared is the positive term, it's vertical. And if x squared is the positive term, it's horizontal. You watching this cheat sheet so you can look at it? And the other main thing is a squared minus b squared equals c squared. And in a hyperbola, a squared plus b squared equals c squared. You're going to graph hyperbolas. So first of all, this is the a squared underneath the positive term. It's always the first guy. So here, a squared is 4, so a is 2, the square root of 4. Everybody get that? And the b is the guy underneath the negative term. So the b is 3. When we find c, it's going to be 2 squared, a squared plus b squared equals c squared. 4 plus 9 equals c squared. So c is the square root of 13. Everybody get that? And you can make that into a decimal if you like when you start making your stuff. Now, h is the same. It's the guy next to the x. It's the opposite of that, which is a 1. And k is the guy next to the y, and it's the opposite of that, which is a negative 3. So the first thing you're going to do is graph your center, which is 1, negative 3, which is right here. And then we're going to look at this equation and decide if it's horizontal or if it's vertical. And this one's horizontal because the x squared part is positive. That first term is the positive one, so it's going to be a horizontal, okay? So if this is horizontal, we're going to go out A and left A. And then, I didn't do that right. I did it again. So you go right 2 and left 2 for your A. So since it's horizontal, the A is the one that connects the parabolas. And your B is going to go up 3 and down 3. Everybody see that? Now I want you to build a box around those points. What I do is I go out this way, up to that point, over this way, down this way, and here. You see how I built a box? No, you're not Xing it out. Those are your asymptotes, actually. They go through the center and they connect the corners of your box. Your box is your guide as to where the parabolas are going to be, okay? So they want you to find the foci. We can do that in a minute. I'm not worried about that. That's just following a formula. So what we're going to do now, these are the two vertices because this is horizontal. So you can draw it and find your vertices. You don't have to use your formulas, okay? And then what you're going to do is you're going to draw a hyperbola going to the right and a parabola going to the left. And you're done with your graph. And when you do your foci, you're going to find that it goes like inside each parabola. Let's find the foci. I'm going to plot 4.4 negative 3 is 1, 2, 3, 4, and a little bit more, negative 3. There's one foci. And negative 2.4, 1, 2, negative 3 is right here. The foci should always be inside the parabolas. So it is, so we're good. It ended up in the right place, okay? So this is your graph. Your graph has a box. It has the two asymptotes. It has the two parabolas facing left and right because this is horizontal. And then it has your foci and your center. Okay?
Okay.
All right. So the A squared is always under the positive. It's always the first guy, this guy here. So if that's A squared, what's A? 6 is correct. B is always under the negative guy. So if B squared is 36, what is B?
6.
You see how they're the same there? So if we found C, it would be A squared plus B squared equals C squared, which is 36 plus 36 equals C squared. So it's the square root of 72. Somebody turn that into a decimal for me. All right, so we have A, B, C. H is the guy next to the X with the opposite sign.
Oh, 3.
3. K is the guy next to the Y with the opposite sign. Somebody else?
3.
Yeah, next to the Y. 2.
2. Sorry.
All right, now we start graphing. Center is 3, 2. Graph it. And then, is this going to be vertical or horizontal?
It's going to be vertical.
It's going to be vertical. So let's start doing our... So we go up. In this case, it doesn't matter because A and B are the same. But we go up A, 1, 2, 3, 4, 5, 6. Down, 1, 2, 3, 4, 5, 6. And then we go 6 to the right. And we go 6 to the left. And we build our box. This guy has a big box. And then we draw our asymptotes, which means you go through the center and the corners of the box. Pretend I can draw. You can use a ruler, okay? And since this is vertical, the parabolas hug these asymptotes going up and going down. All right? So let's find the foci. This is going to be a vertice, and this is going to be a vertice because it's where the parabolas come out of. The foci, what's the formula for foci? H comma plus C and H comma K minus C. So it's going to be 3 comma 10.49 and 3 comma negative 6.49. Yeah, negative 6.49. So let's plot those points. 3 and 10.49. This is 6, 7, 8, 9, 10. It's up here is your foci. And 3 and negative 6. This is 1, 2, 3. Did I draw that wrong? Oh no. 4, 5, 6. I plugged it into the formula.